everybody. Thanks for coming here. Another GerritMeets. I actually haven't counted how many we are on now, but I think it's in the region of 10. So that's pretty good, I would say. Today we're talking about cache-chroniclemap and caches in Gerrit in general. Quite exciting, actually. I don't want to jinx anything, but there's a great demo on the plan. So let's see how it goes. Let's get started. So let's talk about us for a second. I'm going to keep this short. So GerritForge, if you don't know us, we've been part of the Gerrit community for a long time. I think you all know us by now. We contribute to a bunch of things, including Gerrit, all of its plugin, JGit as well, and we're the host of GerritMeets. And then finally, if you're interested in having Gerrit as a service on GCP or working or speeding up your Git on any Git SCM hosting service that you're using, reach out to us. That's what we do. But yeah, let's come to today. So today's agenda, I need to see it there. So I'm going to give a quick intro on caches and why they're so important for Gerrit. H2 and some of its limitations. Now, by no means I'm an H2 expert, and hopefully, I think maybe in the May meetup we will have someone talking specifically about H2 caches. But today I'll just give a quick introduction on what is H2 and some of its limitations. Then Tony will take over from me and do a deep dive into cache-chroniclemap. We'll then have a demo, fingers crossed. It's a complicated one, so Tony has this, I'm sure. And then nothing is perfect, so we'll also talk about some of its pitfalls. And then, answer any questions. So if we want to move on from here. So why are caches so important in Gerrit? So caches in Gerrit power a bunch of things, and they provide us with faster UI and API access. They decrease load on external system. Think of your LDAP provider. So we can cache those calls. They also reduce load on your local file system. So every time that JGit is wanting to look up objects, it doesn't need to go to disk constantly. If you're using a cloud provider for your disk, this is also going to impact the cost of the service and reduce it massively. And then finally, they also obviously improve query speeds among other things. So I just wanted to give you an idea of some of the things that are cached in Gerrit. I find it curious sometimes, but the first time I started, I didn't realize that the file diffs that you see in the UI are cached. I think that's pretty cool. Git tags are cached, the order of your permissions and the permissions themselves, the configuration files are all cached, the details of your projects, the details of your changes, everything. Well, a lot of things. There's tens of caches in Gerrit. I could go on. They're all documented in the documentation. Plugins can contribute new one. So they're extremely important. And if your cache is not performant, your Gerrit is not going to be performant. They even impact reindex operations, especially online. Extremely important component of Gerrit. So moving on, the cache backend is extendable. It's pluggable, like all things in Gerrit. You can use different technologies for what cache backend you want to use, and H2 is the default. But what is H2? So H2 is essentially a SQL database that lives in the JVM. So yes, it's embedded in your JVM, and so tied to that JVM as well. We'll talk about that in a second. And also, if you go on the documentation, you will see that they mention that there is an in-memory and a persistent version of H2, and H2 can do both. Gerrit, and what we're talking about today, is the persistent layer of caching. The in-memory caches, so when Gerrit is running, that's actually done by Caffeine. But today we're talking about the persistent layer. What is H2 is not, though, is a key value store. Obviously, being a database, you can use it as a key value store, but that is not what is born to do. That's a first red flag in my opinion. So let's talk about some of its limitations. Some of them are quite well documented in this issue that I mentioned here. And if you want to have a history of why it was needed to start looking at different implementations of caches, go and read some of the comments on this issue. On the mailing list, there's also some threads dating back, I want to say, to 2011, where Sean himself was saying that H2 is really good for like playing around essentially, but we shouldn't really be using it in high concurrency production systems. So yeah, the limitations of H2 have been known for quite some time. To mention the main ones, out of vacuuming is one. So when your cache starts growing and growing, H2 will eventually decide to start compacting the space it occupies on disk. And this is done in a blocking manner. So if you've got high concurrency operations, you will start seeing block threads, which nobody really wants to see. And Tony will show this in the demo afterwards. Obviously, this will cause latency spikes in your Gerrit operations, and yeah, it can lead to delays in your UI. Also, in general, it works with blocking operations. So if you have high contentions on your caches, you're gonna struggle with that. And you're gonna find threads that are stored waiting for the lock to be released. And then finally, it's not distributed, so you cannot have different JVMs accessing the same cache files, which is something that could be interesting for if you've got a higher availability setup, for example. It is true, H2 V2 has improved things and has solved some of the problems, and actually, again, if all goes well in the demo, it's actually a massive improvement on H2V1. Do keep in mind that H2 is a core component of Gerrit. So and that is why I believe Gerrit only updated to H2V2 in the last 2 months. But as I'm mentioning, these issues have been around for years. And cache-chroniclemap was released, Luca, 6-7 years ago, something like that, our cache-chroniclemap. So you will see the difference in performance between H2V1 and cache-chroniclemap is, I would say, astonishing. H2V2 performs incredibly better, but still has some of the same limitations that Tony will speak about. But anyway, some of the improvements it has brought, mainly it's multi-threaded, so it can improve performance at startup when it needs to read, when the caches are really big and it needs to read those. And also, you can do hot snapshotting, so this means that you can take snapshots while the caches are still accepting writes. So there's a lot of content today on ChronicleMap, so I'm going to leave you with this. And Tony, yes, take it from here.
All right, cool. So maybe let's start from the obvious. So what is ChronicleMap? Not many of you probably have heard this name before. Certainly we didn't before we started investigating this. We wanted to find a good alternative for H2. Following what Danny said, H2 is a the caching system is pluggable in Gerrit. So we started looking out there for alternatives and what would be suitable to be a good candidate to replace H2. And when we stumbled up on the ChronicleMap website, we just read some of the description that they do about the ChronicleMap library that they implement. And so if you head to GitHub and you look at the description of this, you will read that ChronicleMap is defined as a super fast in-memory non-blocking key value store, which is especially designed for low latency. In particular, this is used a lot for trading and financial market applications, especially because of its really low latency. So obviously, all of these are really good properties that we would want in our caching mechanism in Gerrit. So if we can achieve to implement all of these, then we have a win, right? And last but not least, all of this is also open source. ChronicleMap also comes in a enterprise level shipping package that the company behind ChronicleMap sells to customers, but luckily enough, most of the features that we actually need are in the free tier layer. So we managed to get everything by just using the open source library. We don't need to tap into the enterprise level library, which mostly tackles issues like replication across different nodes and redundancies and so forth. So again, ChronicleMap makes really strong claims about its performance. They promise that in some circumstances, at least, they can perform read and write queries in less than a microsecond, and they share the benchmarks on their website. They promise really high concurrency. They say they can scale up to the number of hardware execution threads in your server. So the beefier your machine, the higher the concurrency the Chronicle map can handle. And also they promise the read queries never block each other, which is really appealing if you're trying to build a caching system for Gerrit. And last but not least, they provide persistency. So if we are hoping to replace H2 with a library that implements caching for us, we also need to have something that implements persistency, because as you guys know, Gerrit has not only in-memory caches, but also persistent caches. And luckily enough, this is a feature that is provided in the open source tier of the Chronicle map. So we have all the ingredients that we need to build an alternative to H2, and this is exactly what we did at GerritForge quite a few years ago. I believe the first implementation came up around Gerrit 3.3 or 3.3, I think it was. Yeah, unless I'm mistaken, it could be 3.4. But so this is available. It's been available for quite a while. So let's see how Chronicle map achieves these promises that is making. And you will see in this presentation that they made some choices that are quite bold, maybe even exotic, and but the benefits that they bring on the table are definitely something that it's worthwhile. And the first of these design choices has to do with memory. So when you think about Chronicle map, you have to think about it as an implementation of the concurrent map API, basically. So it's pretty much a concurrent map that stores entries off heap. So what does this mean? Well, unlike standard collections, which store data in the JVM heap, Chronicle map keeps these entries off heap, meaning that they are outside the managed memory or management of the JVM. And this is important because off-heap storage reduces garbage collection overhead a lot. And this is one of the biggest performance bottleneck when it comes to high throughput applications. So this is really important, and we will see more of this later. Also, Chronicle map goes even beyond this and allows zero allocations on queries. So what does it mean? So again, usually in a traditional Java collection like hash map, when you're retrieving a value from the hash map, Java typically allocates a new object for the key and the value that you are accessing, and creates a temporary object that before handing that to you. And this object eventually will need to be garbage collected, which again will lead to a performance overhead. Chronicle map takes a different approach. It basically, as we've seen, keys and values are stored off heap, so outside the JVM heap. And instead of creating new objects, when you ask for a key value to be retrieved, Chronicle map reuses the same memory mapped structures, and it gives you exactly that value to you. So the retrieved values are written into these pre-allocated key value instances, which again we will see more about later, and this avoids unnecessary object creation, which would bring an increased GC pressure on the heap memory. And last but not least, Chronicle map also implements direct read and write access to the off-heap memory. So one of the biggest inefficiencies in traditional data store is the serialization and deserialization of overhead when transferring objects between memory and storage. And instead of copying data back and forth between on-heap and off-heap memory, a Chronicle map provides a direct access to the data which is stored off-heap. So the values are read and written in place. And this is especially beneficial in low latency applications where every millisecond counts, such as the financial trading market for which Chronicle Map was created for. But this is also really, really good property to have in a caching system. So again, all of this reduces garbage collection because you don't actually need to have lots of temporary extra objects that are created in between. So let's take a look how the persistence is implemented in Chronicle Map. This is very relevant because you will have to deal with this when it comes to configuring Chronicle Map. So it's important that we get this bit right. And the persistent feature of Chronicle Map is what allows us to, implement persistent caches. And the way it works is that Chronicle Map stores its data into what's called a memory mapped file. And a memory mapped file, it's exactly what it says on the tin. Is a file which is mapped directly into memory for fast read and write access. And this file is accessed like an in-memory data structure, avoiding costly read-write operations that would have happened on disk instead. And this is ideal for handling large data sets that do not fit entirely in RAM, but only the needed portions are loaded into memory as needed. And since it bypasses the traditional file I/O, the performance are significantly improved. So this is a way of storing memory map files off heap, which basically allows a really fast access to these data structures, so aka our cache data. And when these memory map files are flashed on disk, they become these DAT files. So if you're used to see the usual H2 files on disk in the traditional with the traditional H2 backend, you will actually see that when you install cache-chroniclemap, these H2 files will actually be replaced by these DAT files, which contain the key value pairs, the metadata, some internal indexing. And pretty much they have everything that is needed for Chronicle Map to serve the data when you request it. The flashing on disk, if you're wondering, depends on the operating system. So Chronicle Map makes no guarantee, gives no guarantee as how frequently this happens. Again, this is under the control of the operating system, but all the data is guaranteed to be written to disk when the map is closed. So if you orderly shut down Gerrit, the flashing of the memory happens on disk, and that's guaranteed by the library. And if you recall, one of the pillars and one of the bold promises that Chronicle Map made was a really, really high concurrency. How is this achieved? Well, by what they call to be a lock-free read-write access. So unlike concurrent hash maps, which again uses synchronizations and compare and swap operations and so forth, Chronicle Map takes a different approach. So instead of locking the entire data structure, it only locks the specific entry that is being updated. And this allows threads to be read and written simultaneously. So this is where reads can happen without blocking the writes. And you might wonder, how this is achieved, right? And they do this by implementing this optimistic concurrency control, which pretty much is, instead of locking the entire map or blocking the threads, Chronicle Map allow multiple threads to attempt a modification simultaneously, optimistically thinking that this will go fine. And before committing the update, however, it checks if another thread had modified the same key during the process. If a conflict is detected, then it prevents overwriting and forces the operation to retry. So you have some internal versioning of each entry, which again is kept in that metadata section in the data file that I was telling you about. And if the entry version has changed since it was read, then the update is automatically retried. So optimistically, this will not lead to any locking or any problem. If a collision is detected, then there is an automatic retry. And because these memory mapped files do not require any exclusive locking from the JVM, which is instead, you probably are aware of the fact that H2V1 requires an exclusive access from the Gerrit instance. And that's why you usually see the lock.db file on disk, which is also what's preventing that cache from being shared across multiple instances. Chronicle Map doesn't have this limitation. So they thought of these memory map files to be available through multiple JVMs that will be able to access the same data in real time without any issue. And this is cool because it does open the door for distributed caching, which at the moment is a no-no for Gerrit installations. And if you have a multi-site installation or an HA installation, each node will need to have its own copy of the data. Cache Chronicle Map doesn't have any technical limitation that would prevent the data from being shared. Exactly. So this would be good in HA setups, and it allows to scale horizontally because you can more easily share the caches. So that was a lot. So maybe a quick recap so that we can get everyone on board before moving forward. Super quick comparison between the two approaches, H2 versus Chronicle Map. Classic H2 database is both an in-memory and an on-disk database. On disk, this is represented as the H2DB files that you're very familiar with, whilst Chronicle Map stores all the data off heap, which reduces garbage collection, as we've seen, and in-memory mapped files. So because of this, the GC overhead is actually reduced, and the persistence layer that is chosen by the two different approaches is a DB style storage. Yes, it is a file on disk, but actually that's a full-blown database that is stored within the file, whilst Chronicle Map is a file-backed storage, and we will see more about these files later. And also the way concurrency is handled is a lock-based transactional approach, which is typical of databases with all the ACID properties of a relational database versus a lock-free operations that Chronicle Map provides. As Danny mentioned earlier, H2V2 makes lots of improvements when it comes to locking, as we will see. But the remaining part holds. So we're still talking about a full SQL database, which comes with the SQL overhead of having to, parse queries and executing queries in transactions and so forth. And this is how Chronicle Map achieves the ultra low latency that they promised in their claim. So you might read all of this and raise your eyebrows and say, okay, but where is the catch? Like, how do we get all these goodies without actually having to what's the price? Like, how much is this going to cost us? And that's a good question, because there is no such a thing as a free lunch, and this is still the case for Chronicle Map. So the problem with Chronicle Map is this very, very important concept of pre-allocation. So if there is one takeaway that you take home today, is exactly this: that Chronicle Map, it's very picky and it wants to be told things at the very beginning. So what does it mean? Chronicle Map wants to know the number of entries that your cache is going to hold. So basically, you will need to define at configuration time, and we will see this later, how many key value pairs should be prepared to hold. So for each cache, so if you're thinking about accounts, projects, you will need to have a really, really intimate idea of how many entries that cache is going to hold. Because internally, this affects how the off-heap memory is organized and how this is pre-allocated. And not only, also, you will need to have a really good understanding of the average key and value size. This is because Chronicle Map uses a fixed size memory map region, and it needs to know roughly how large each entry will be, because this will help to lay out its internal structures more efficiently. And also, like, if you don't get the first two rights, you can basically have a margin of error, which is called blow factor in the Chronicle Map world. So this basically defines how much the map is allowed to grow beyond its configure entry count before it refuses to insert any more entry. But let's take a closer look, because it will make sense if we actually have a visualization on how this pre-allocation works. So imagine we are we are outside the JVM heap, so we are off heap. And what Chronicle Map will do, it will read the configuration that you specify, and it will work out how much segments it will need to allocate. This is a function of the number of entries plus the sum of the average sizes plus the space needed for metadata and some other internal structures. But once Chronicle Map works out all of this, it will divide your off-heap memory into segments. And each segment, you have to think about it as an independent hash table. So each segment will hold contiguous memory region, which are divided into equal size chunks. This is true for each segment. And when a new entry is put into the map, then Chronicle Map will find a free run of one or more chunks. They are sufficient for the entry data to be stored. And then it will mark this chunk as used, and it will actually keep an internal bitmap that will help find free chunks from utilized chunks very, very quickly. So it might be that the key and value that you're storing are a perfect fit for the estimate that you give at the beginning. So if you're able to accurately specify average sizes, you will be able to maximize the memory allocation that Chronicle Map did. So if the size is set correctly, Chronicle Map can pack entries tightly into memory, minimizing wasted space and avoiding what we will see later as our enemy, which is an expansion of the cache, which we don't want. So this getting these estimates right leads to faster lookups and inserts, because each entry just fits in the expected chunk size. This is different from overestimation. So if you thought that your key and values needed to be bigger, but in reality they are smaller, this, it won't break anything, but you're just getting a higher memory footprint, which is unnecessary. But the worst that can happen is actually when you have an underestimation. So if the average sizes are underestimated, then the map might actually run out of space. Imagine you're trying to store a key value pair, which is really, really big. In fact, so big that it cannot fit in the free chunks that you have available. Well, in that case, what Chronicle Map will do, it will just add an additional segment. It will, again, split the segment into chunks, where each chunk is a function of the averages that you specified at configuration time. And then it will store the additional keys, or the additional key that couldn't fit into the memory. And again, once this is full, and then it will allocate an additional tier, which again will be split into chunks and so forth. So you will end up with a multi-tier map, and the number of times this can be expanded is what's driven by the bloat factor, which, as I said earlier, it's a margin of error. Basically, if you set a higher bloat factor, you're allowing the map to allocate more memory when needed rather than failing. And this can be useful if you're unsure about the workload, or if you want to allow the map to tolerate spikes in the data volume. You need to remember, though, that this is costly because multi-tier lookups are much slower than the single-tier lookup. So if you set the bloat factor of 1, you're basically saying I don't expect, I'm not allowing for any growth. I expect this map to be to hold at most the number of entries that I specified. If you're not sure, then you can work on top of that and allow more entries to be stored at the price of a higher latency. And why am I showing you all of this? Well, because this is important, because if you're really seriously thinking about using cache-chroniclemap, you will need to come up with these values. So what do we have here? So on this left column here, we have an installation of Gerrit that uses H2V1. Specifically, this is a 3.10.4. And up to version 3.11, you are stuck with H2V1. So no matter what, unless you're on master, you're dealing with H2V1. Then we have the latest master on this middle column here, which is obviously running H2V2. And then on the right, we have a version of master that is running ChronicleMap. Okay, and we added an additional plugin to these three installations, which is very, very simple, and is this one. So we added a plugin that just exposes an endpoint, a put endpoint, which just calls a cache put. So it receives a key and a value as an input and inserts that key value into the map. And the plugin is the same for all of the Gerrit instances. So this is basically a cache, which is called internal cache, because I'm creative when it comes to naming. And keys are strings and values are strings. Okay, so what happens is that we're going to run one of these simple scripts here. Maybe I'll just open one of these to show you. And what this is going to do is going to just put a key value that we have here into this endpoint here. Okay, so if you're wondering, the keys are and values are just alphanumeric strings. The keys are 64 bytes, and values are 512 kilobytes. So quite big values. Okay. We also have a Prometheus that is running here, which is here, which is collecting metrics that I would like to show you. So we will be able to count how many entries are in the cache and what's the pressure on the memory for this addition. One thing before we run the demo is that I want to show you the configuration of cache-chroniclemap. Let me make this a little bit more visible. So the way you configure it is you put cache-chroniclemap in the lib, and then you just install the module. This is all documented, so don't worry about it. It's really simple. You just add this line to the Gerrit stanza in the config, and then you configure the cache. So in our case, we are allowing 60,000 entries at most with a max bloat factor of 1. So I mean, this is a demo, so we know exactly that we're not going to go over that amount. And then you specify the average size and for the key and for the value. And if you're wondering where these values come from, as I said, keys are 64 bytes, which in Java are 64 characters, which in Java each character takes 2 bytes, so it's twice as that. And this is basically 2 times 512 kilobytes. It's not always going to be that easy. There are caches where you don't really know how much the size is going to be. But in our case, we're lucky and we know exactly. So this is all you need, and you have a configured cache here. If you head to the cache directory, you will see that you actually have the .dat files that I was talking about. In particular, this is the one. And if you look at how much space this is taking, you will be surprised to know that this is already taking 73 gigabytes. Okay, you might be surprised because this cache is empty at the moment, but as I said, cache-chroniclemap pre-allocates space. So this file already contains all the segments and the chunks as we discussed before. So with no further ado, we run the simulation. So now I'm gonna tail the HTTP log, so you can see that there is actually some action going on. So okay, so we tail HTTP log. Okay, you can see Prometheus is scraping each instance to get information out of it, and there you go. So we're gonna run 1, 2, 3. You see that now there are lots of put calls to this cache metric put endpoint, which are basically just inserting lots of entries into each single cache. And if you're looking at the cache directory of each one, here you see the H2V1 with the usual lock files as we discussed earlier. And if you're looking at the internal cache here, and you will see that this is actually growing over time. So 1 gigabyte, there you go. So this is actually growing over time, while ChronicleMap is fixed to the 73. Okay, anyway, so that's pre-allocated. Let's add to Prometheus. Okay, so here you actually see the behavior of the entries. So we have, this is cache-chroniclemap. You can see how we are fast, very quickly adding more entries to it. Then we have H1V1, which it's much slower, extremely slower when compared to ChronicleMap. In the meantime, as H2V2 catches up, I can start showing you a few things. So first of all, why is H2V1 so slow? Well, to the Gerrit installation for it, which is this one, we're going to log in, and we're going to head to Java Melody, which probably you're all familiar with. And we're going to take a look at the thread dump. This is very aggressive, a very aggressive demo. But so you can see that we have the H2 commands that are actually blocking the threads. And this is exactly what we were explaining earlier, where the writing to the internal cache is completely blocked. And this is because by default, H2V1 uses table level locking, which again is fixed by H2V2. But because of this really poorly concurrency handling, you actually will perform much more slowly than you could if you were to perform to have a better concurrency, like in H2V2 or in ChronicleMap. Also, you can see how this is a graph that shows the heap that is actually used. You can see how H2V1 is really is heavily using the heap. And you can even see that you have some areas where you don't have any metric, any data point. And the reason is that you actually have the collection of the metric, which also requires to read data from the cache, is blocked by the poor concurrency handling. So it's not able to provide endpoints, which eventually leads to these gaps. Sorry, H2V2. You can see that is also using heap quite a lot, even though not in the same measure of H2V1. But if you look at the heap utilization for ChronicleMap, you can see how consistently lower this is. And now we can understand why, right? Because we know that data is not actually stored in the heap at all. So when you go and look at the pressure this has at the GC, and this last graph that we're looking at is the time spent, the number of milliseconds spent doing GC. You can see how H1V1, and that means every Gerrit installation up to 3.11. So unless you're a master, you are affected by this behavior. Has, you know, H2 has a really big impact on the GC pressure that your Gerrit experiences, and all these obviously will compete with all the other operations that you're doing, your Git operations and your API calls and so forth. But you can see how if you're taking H2V1 out from the equation, you will see that actually cache-chroniclemap has a consistently lower number of GC pressure on the heap, even when compared with H2V2. So you can see this is the time that H2V2 is spending doing GC. And now hopefully even H2V2 caught up a little bit, and it did. And you can see that H2V2 is also affected, even though it's performing better than its counterpart H2V1. This is also affected by the blocking of the. You can see this is also affected by H2V1 by the blocking. It is doing it in a better way, but is not immune to it. You can see how actually ChronicleMap has a much more smooth and linear execution.
And so, sorry, if you go back to V1, you can also see how it's not keeping up at all with the pace of H2.
Yeah, absolutely. H1 is the exactly. it will eventually get to a out of memory in the heap space, and it's just blocking. So yeah, again, up to 3.11, this is what you get, the worst performance, unless you use a ChronicleMap.
This is proper mad, eh? This is
when you go to master, you will get a better performance because you will get H2V2. However, you still see that there are some cases in which this is suboptimal. Okay, so yeah, a couple of challenges of chronicle mapping Gerrit. Maybe you were already thinking about these things. You know, caching also needs to implement additional properties on top of the ones that we mentioned. One of those is obviously eviction. You know, you need to do last recently used. You know, evict based on time, eviction based on size, and cache-chroniclemap doesn't come with this out of the box. So we actually had to implement this on top of the cache of the ChronicleMap library in order to allow Gerrit to still honor the configuration of the evictions. So Jacek in particular did a great job in doing this, and the way we are doing this is by adding an additional data structure that we keep a sort of like index that we can consult in order to know which entries will need to be removed from the cache-chroniclemap, and this is proven to behave very well. I'm going to stress again on this point. ChronicleMap, you know, it's tricky to estimate the entries and sizes. So if you're a Gerrit admin out there, is not super intuitive at the beginning to understand how to do it, but we will go through some tools that can help you doing that. And there are some caches that have a higher variance in their key value sizes. Right, in the demo I gave you, keys and values have fixed size. It's very easy to define their averages. But if you're thinking about diff caches in Gerrit, you might, you know, intuitively, you will see how you might have one entry that is very small because it represents a very small change that may be modified just one line. And then you have a diff entry that is actually quite big because it touches many lines across many files. So you might have caches that are more suited to get to be configured in an easier way, and others they are more difficult. And you will need to monitor and retuning over time. Cache-chroniclemap is great when it comes to metrics and monitoring. There are many metrics that will help you understand if your cache is bloated, if it is expanded, how many times, and so forth. So you can find all of this in configuration, in documentation. And as I said, there are some tooling that will help you in this effort. Since Chronicle Map is one of the first open source alternatives to H2, it's very likely that your Gerrit instance is been running with the default H2 cache backend. And so the idea is to read from the actual persistent H2 caches into output to calculate the averages of the keys and the values, and then to output this in the form of a cache-chroniclemap configuration template. So you can just simply run this command. You don't need to install cache-chroniclemap as a library. You can just install it as a plugin, just with the intention of having this plugin available to you. Sorry, this command available to you, and this will output. It will analyze the H2 caches, and it will output the and will output the configuration. And you can use a similar approach to auto adjust the caches, the Chronicle Map caches that you have, by running some sort of like periodic checking of what's the current status. If you're diverging from the configuration that you originally thought, whether you have new caches, maybe you run a migration from 3.5 to 3.8. Now there is a bunch of new caches that needs to be configured at the beginning. What value should be provided for those caches? Yeah, so what you can do is you can execute this this command that is available to you that is auto adjust caches. It will do a similar job, but in this case it will analyze the pre-existing Chronicle Map caches, and it will come up with the best averages for that point in time and how many entries you have and so forth. So conclusions. Chronicle Map, it's well suited for large scale installations with lots of concurrent reads and writes. It doesn't mean that you couldn't use it in any installation. It's also true that smaller installation will just do fine with H2. So probably you don't need to go through the effort of configuring the plugins and the pre-allocation and so forth. But if you have a large installation with lots of concurrent read writes, you will definitely get an improvement by using cache-chroniclemap, as we've seen, definitely up to 3.11, probably with some terms and conditions, even after that, depending on the type of traffic that you have. Chronicle Map requires pre-allocation of key value sizes, so this could be daunting at the beginning, even though there are ways and tools to help you out, and you need to monitor over time. And you will get back consistent latencies. You will no longer have outliers, that cache reads that will take much longer time just because you happen to be blocked by an auto vacuum or by another query that was running at the same time. So we'll always get consistent latencies. And all of this for a much smaller impact on your heap memory, and therefore GC, which can be used for better, more useful tasks than this. And that's it. Questions?
All right, thanks for that, Tony. Very impressive demo, in my opinion.
Yeah, no, absolutely. Well done. So we've got lots of questions.
Yeah, we're not going to go through them all. We've got a few minutes, so I'll pick the most interesting for me. How can you store the cache-chroniclemap files on a shared NFS and use them by multiple nodes on Gerrit HA setups?
So great question. So there are no technical limitations for this. As I said, there is no exclusive lock access to the memory mapped files. However, I don't think this just works out of the box at the moment. We haven't tested this as a primary use case. So the answer is not yet, but it should be very trivial to implement.
Okay, thank you for that. What about cache defaults with Gerrit? Would they be suitable for cache-chroniclemap as well?
Great. Again, great question, because you don't want to run on defaults, right? Running on defaults is suboptimal by definition, because you're not utilizing your memory segmentation in the best way. Because we were aware of it, we actually decided to emit a metric in. You will see this in Prometheus or wherever you get your metrics from, that will tell you how many caches are running on default. And in the logs, you will see details about which caches are running on default. And that's really a hint for you to go and maybe run the SSH command that will analyze those caches, because that will give you an idea of what initial key values and averages you should be configuring for those, and this will really allow you to catch up with the upcoming of new caches, and actually configure them in a more optimal way.
Yeah, I just wanted to add one thing though, because you can run on defaults and Gerrit will just work fine equally with H2 and Chronicle Map, because you may think that, okay, cache chronicle mapping means I need to do a lot of work, of tuning, whatever. In H2 it's just fine. No, I believe it will work as badly as we know it works with H2, because if you get Gerrit and you don't tune the caches, and I believe many of the people that are watching us, they know that if you don't tune Gerrit caches, Gerrit performs very badly. And I would say it's not going to be worse with cache chronicle map compared to H2. And even if the cache, they are completely misconfigured, cache chronicle map will still work. Of course, performance will not be ideal, right? So it's something that you can move on to cache chronicle map, and you can tune it, let's say, before going to prod, I will say. Lastly, as GerritForge, we do a lot of work also to do certification of Gerrit binaries, and we also include cache chronicle map if, let's say, the people wants that. It means that if you guys are interested, so reach us to us, and we can definitely go and do some certification of Gerrit binaries with cache chronicle map in your setup, right? And we can help you in tuning those values.
Absolutely.
Thank you for that. And then I think we've got time for one more. How robust and supported is the cache chronicle map? H2v1 maybe is lower, but widely used for over a decade. What about cache chronicle map with Gerrit?
Well, so first of all, a disclaimer: we've been using Cache Chronicle Map in GerritHub.io for many years at the moment, and we're really extremely, I would say, happy.
And plenty of our customers as well, I would say.
Absolutely, and so we're really happy with the results. And I think the demo should have given you a hint as to why we are happy with it. The beauty of having this in a plugin is that you're not really tied to your Gerrit version. So yes, it might be true. H2v1 was there for a long time. It's also true that in order to get upgrades and bug fixes on that, you actually need to wait for Gerrit patches and greater versions. And to get H2v2, you need to. I don't know which versions you guys are on, but you will need to get all the way to master, which might be difficult for thousands of other reasons, right? Having this in Cache Chronicle Map plugin allows any bugs to be fixed outside the Gerrit core. So the life cycle of the plugin and the throughput of fixes that we can do is much, much higher. So I would say that it's more robust because of the nature of the plugin rather than having to get on board of the Gerrit, upgrade plan.
Yeah, just to add one thing. So Cache Chronicle Map was created when Gerrit was in version 3.2. So it means, 3.3. So it means that as long as you're running Gerrit 3.3 or later, you can always go to Cache Chronicle Map and get the level of performance that Tony mentioned. And lastly, so you have seen in the graph that there were some broken lines, right? When you need to translate the broken lines in the graph, like the people is chasing you saying that Gerrit is not responding, because that's actually the case. So basically the Gerrit heap is such in a huge pressure that the JVM does not respond during those times. And we ended up going to Cache Chronicle Map because we had those issues on GerritHub.io, right? And we were seeing why Gerrit is not responding. And they were looking at the thread dumps, and we were seeing that basically H2 was monopolizing the CPU, and H2 was basically blocking all the threads. And everything you do in Gerrit, you're accessing caches. If caches are blocked, Gerrit is blocked, right? So we did that piece of work many years ago, and I have to say we never had that problem on GerritHub.io ever again, right? And we keep on updating and porting to newer version of cache-chroniclemap. And lastly, so if you're looking at HA and you want to get distributed cache, the guys that develop cache-chroniclemap, the goal gives also a completely distributed version of the caching across different nodes. And this has been widely used, and is a kind of British technology because it's been developed for the stock market in the UK. And the majority of the software they are doing, let's say, real-time trading, they use cache-chroniclemap in distributed fashions as well. So if you guys are interested and you're looking at HA or also multi-site, you want distributed caches, then yeah, reach us to us because yeah, maybe that could be the option for you.
All right, and I think very last one, just because I like it, but then we're going to be done. Yeah, exactly. People need to get back to work as well. Will the cache-chroniclemap module documentation be updated, particularly with example of the auto resizing? I guess I can take this. We probably should, and we probably should put some screenshots from this demo and see the kind of improvements you can get. Some links, and yeah, we should definitely do that. We should definitely do that.
Yeah, good idea.
All right. I think that's it. Thanks, Guy. Thanks, Tony. That was a great work from you. Important. Next time we're gonna have Google coming back to speaking at an event at Gerrit, so that's great, together with Accenture. So they're going to be presenting the Horizon platform, which is a new platform that they're going to be releasing fully open source to accelerate Android platform development with a bit of a hint to automotive for now, but more generic going on.
Yeah, and I believe I always loved the Google presentations and the events because really gives a sort of, let's say, reference point of where we should aim to in terms of organizing the software lifecycle. In this case, Google is telling us how they propose to do the software development lifecycle when you develop software for cars. Right? And I believe many of the people they are watching this presentation and remotely, maybe they are a car manufacturer and maybe they are interested to see, let's have a look how Google does it. That is going to be next time.
The event is already live on our GerritMeets page on meetup.com. So if you want to go and register, it's going to be remote only for once because we're busy traveling. But yeah,
if you live in London, we can make an exception.
If you live in London and want to come and have a lunch on Minds, that's fine. But yeah, so yeah, see you all next time. Thanks, guys. Bye.